Let's take a look at this problem where we have been asked to solve an equation for x that contains several fractions. As you can see, we have denominators of all different kinds in this equation. So when that happens, and if you have the advantage of an equal sign, that is that it's an actual equation, you get to do something really effective in the first step, which is sometimes called fraction busting. This is a way where you can actually get rid of those fractions in the very first step. And the trick to beginning this is to look at those denominators, in our case 6, 3, and 4, and ask yourself, what is the lowest common multiple of those three numbers? In other words, what's a number that they all go into evenly? And so in that point you might say, well, they all go into 12, don't they? So that would be what's called the least common denominator, or sometimes least common multiple. You want to use the lowest number that you can. If you had maybe thought 24 would be a good choice, while they all go into 24, and that would work, it would just lead to larger numbers later when you're going to solve the equation. So what you do with your least common denominator is you're going to use the property of equations that allows you to multiply both sides of an equation by the same number, and it will still keep it with the same solutions. So we're going to multiply both sides by 12. Now if I multiply the left side by 12 and the right side by 12, I would need to put parentheses around there to indicate that it's the whole side that's being multiplied by 12. But what would happen next if you were doing this is you would have to multiply the 12 onto the 2/3 and onto the x minus 4 over 4, because that's how you distribute a number into parentheses when there's a plus sign in the middle. So in order to save a little time, I like to actually write that in at the very first step. So I'm going to multiply all three of the fractions by 12. Notice that I'd left some space ahead of time for those 12s to squeeze in. So anytime you see a question with fractions, you might want to write your problem down with lots of extra space so that it keeps it neat and you don't lose track of what you're doing. Okay, so the next step is, of course, to try to get rid of those fractions. In other words, fraction bust. And what we can do is we can use the property that 12 is like 12 over 1. And we know that if you are multiplying 12 over 1 times x plus 5 over 6, that you can reduce on the top and bottom. So since 6 and 12 both have a common factor of 6, you can reduce by 6. 6 goes into 6 once, 6 goes into 12 twice. And so what you end up bringing down from just this part here is whatever is left that didn't cancel. So in this case, that would be the 2 and the x plus 5 in the numerator. And then luckily for us, we don't have to bring the denominator down anymore because it's just a 1. So that is really the goal of fraction busting. All right, let's do the same thing for the next term. So here we have a 12 and a 3. 3 goes into 3 once, 3 goes into 12 4 times, and then when you multiply 4 times 2, you get 8. Plus, let's bring down that sign, whatever it may be. And then lastly, we get to reduce the 12 and the 4 here. 4 goes into 4 once, 4 goes into 12 3 times, and then just bring down what's left, which again is just going to be the numerator parts. The 3 and the x minus 4. Notice I brought down the parentheses as well. That's going to matter because in the next step I'm going to need to distribute over those parentheses. Now you're looking at a fairly basic equation, but let's finish it up. Let's clean up both sides by distributing over the parentheses. So 2x plus 10 equals 8 plus 3x. And then remember, this is a positive 3, so when you multiply it onto the negative 4, you get negative 12. We could combine some like terms over here on the right side. So left side stays alone. But 8 minus 12 is negative 4. And then plus 3x comes down. Finally, we need to isolate x. So if we want to, we can subtract 2x from both sides, or we could subtract 3x from both sides. but I like positive numbers, so I'm going to subtract 2x from both sides, giving me over on this side 10 equals negative 4 plus x. And then lastly, I'm going to add 4 to both sides to get the x isolated, and that gives me 14 equals x. Hope that makes sense and helps you with those fraction-y problems in the future.